Welcome to The Explainer. Today, we are diving headfirst into a battle over the very nature of reality itself, a conflict fought not on some dusty battlefield, but on the absolute farthest frontiers of pure mathematics.
You know, it really all boils down to one huge question. And for decades, this question has pretty much split the world of mathematics right down the middle, sparking this massive intellectual Cold War over the true shape of infinity.
So, in one corner, you've got the tame universe folks. They believe that every single mathematical object, no matter how wild it seems, is ultimately definable, that we could, eventually, create a complete catalog of everything. But in the other corner, you have the wild universe crew, and they argue that some things are just fundamentally unknowable, that reality will always outrun our best attempts to pin it down.
Okay, so right in the middle of this huge debate, a new philosophical framework popped up. It was, honestly, kind of like a prophecy. It was called the Infinity Ontological Canon, and it made three incredibly bold predictions about what our universe would look like if the wild side was right all along. The canon basically laid out a philosophical treasure map. It said, hey, if the universe is really wild, here are the three big clues you should be looking for. It gave mathematicians a set of signposts to prove, once and for all, that reality is truly untamable.
First up, divergence. The best way to think about this is like a map. Let's call our map of reality, the part we can actually define with logic and language, HOD. Now the actual reality, the whole territory, is called V. Divergence predicted that V would always be bigger than HOD. The territory is always vaster than our map.
All right, the second clue on our treasure map was something called structural reflection. This predicted that the structure of infinity wasn't just some boring straight ladder where you just climb from one level to the next. No, instead, it would be this beautiful, mind-bendingly complex web of self-repeating patterns. Kind of like a fractal, you know, where the giant overall pattern repeats itself in all the tiny little pieces. And then we get to the third prediction, and honestly, this one is the wildest of them all: traceability. It claimed that even alternate mathematical realities, universes with totally different rules, should leave detectable shadows or traces in our own. It's kind of like finding footprints in the snow from an animal you were told was completely mythical. So for years, this was all just, well, philosophy, right? Really cool ideas, a compelling framework, but nothing more. That is until a groundbreaking paper in 2025 from Aguilera, Bagaria, and Luca uncovered what you can only describe as the mathematical smoking gun. What they found was something totally new, a new kind of infinity they called an exacting cardinal. And get this wasn't just another number on a long list. No, this was a mathematical entity so powerful, so fundamental, that if it exists, it forces reality itself to behave in very specific ways.
And here's where it gets absolutely mind-blowing. This one discovery, this single new idea, it was like the master key. It unlocked the entire philosophical puzzle, systematically proving all three of the canon's predictions right on the money, one by one.
So first up, divergence. Confirmed. The math was just crystal clear. If you have even one of these exacting cardinals, then V simply cannot equal HOD. Game over. Our map can never be as big as the territory. This single-handedly settled that decades-long debate and overturned a huge competing idea called Wooden's HOD conjecture. The Wild Universe team didn't just win, it was a knockout.
Okay, so what about structural reflection? Well, the exacting cardinal blew that wide open too. It didn't just add a new rung to the ladder of infinities. As the researchers themselves put it, it completely challenges the linear incremental picture of how we thought infinity was all organized. You see, for the longest time, we thought about infinities in a very neat, tidy way. Like a simple ladder, right? You just climb from one type of infinity to the next, with each step being a predictable jump in power. But this new discovery, it just completely shattered that picture. The ladder is broken. The reality is that the structure is this incredibly complex branching web, which, if you think about it, is exactly what the canon predicted with its idea of a complex, reflective, fractal-like pattern. And finally, traceability, the spooky one. What the paper showed was, well, basically evidence of a ghost, an impossible infinity, something called a Reinhardt cardinal. From a totally different mathematical reality, it leaves a footprint in our world. And that footprint? It's the exacting cardinal. The shadow is real. The prophecy came true. Okay, so let's take a step back. This is all fascinating, but why should we care?
I mean, what does a war over the nature of infinity actually mean for us? Well, for one, it gives us some seriously powerful evidence for a pretty profound idea, that mathematics isn't something we're just making up as we go along, like a game. It's a real place, a vast existing landscape that we're just starting to explore.
And that completely changes how we can think about what is true in math. It suggests we don't have to justify new ideas just because they're useful. We can accept them because they fit, because they belong to this deep, beautiful, and coherent pattern. Truth in this sense is about elegance.
In the end, this new map of infinity gives us this incredible paradox. We're looking at a universe that is both absolutely wild and limitless, and yet, at the same time, it's governed by these deep, elegant laws we can actually begin to understand.
And that really leaves us with a final, kind of tantalizing thought, doesn't it? If a mathematical reality this deep, this structured, has been hiding just out of sight all this time, just imagine what other fundamental truths about our universe are waiting out there, beyond the horizon, for us to find.